Our solar system is a captivating place, a realm of endless fascination and mystery. It's a cosmic ballet of planets, moons, and asteroids, all dancing around a star we call the Sun. Each celestial body follows a precise path, creating a harmonious dance that has been ongoing for billions of years. Have you ever gazed at the night sky and wondered about the twinkling lights above? What are they? These tiny specks of light are distant stars, each one a sun in its own right, many with their own planets and moons. How did they get there? How did the universe come to be filled with such an incredible array of stars and galaxies? These questions have fascinated humanity for centuries. Ancient civilizations created star maps and constellations, using the night sky as a canvas for their myths and legends. For millennia, we've looked to the stars, seeking answers about our place in the cosmos. Early astronomers used rudimentary tools to chart the heavens, laying the groundwork for modern astronomy. The ancients wove stories about constellations, imbuing them with myths and legends. These stories were passed down through generations, enriching our cultural heritage. Today, thanks to scientific exploration, we have a deeper understanding of the celestial tapestry that surrounds us. Modern telescopes and space probes have unveiled the secrets of the universe, revealing its true nature. Our journey begins right here in our solar system, a cosmic neighborhood nestled within the vast expanse of the Milky Way galaxy. This galaxy is just one of billions in the universe, each containing countless stars and planets. It's a place of immense beauty, filled with celestial wonders that continue to inspire and amaze us. From the swirling clouds of Jupiter to the rings of Saturn, each planet offers a unique glimpse into the workings of the cosmos. Join me as we embark on a 10-minute expedition to explore the marvels of our solar system. We'll travel through space and time, uncovering the mysteries of our celestial neighbors. From the scorching heat of Mercury, where temperatures can soar to over 800 degrees Fahrenheit, to the icy plains of Pluto, a distant world where temperatures plunge to nearly -400 degrees Fahrenheit, we'll journey across billions of miles, uncovering the secrets of our celestial companions. Each planet has its own story, its own unique characteristics that make it a fascinating subject of study. Along the way, we'll delve into the fascinating processes that led to the formation of our solar system, from the swirling dust and gas of the early solar nebula to the birth of the planets. The intricate dance of gravity that keeps everything in place, ensuring that planets, moons, and asteroids follow their paths without colliding, and the unique characteristics of each planet. From the volcanic activity on Venus to the massive storms on Jupiter, each world has its own story to tell. Our solar system wasn't always a well-organized family of planets. Billions of years ago, our cosmic neighborhood was a chaotic cloud of gas and dust, a nebula adrift in the vastness of space. This swirling cloud, composed mostly of hydrogen and helium, held the building blocks of everything we see today: the sun, the planets, and even ourselves. Imagine a giant cloud of interstellar dust and gas spread out over a vast distance. This cloud, the solar nebula, was the birthplace of our solar system. This nebula, disturbed perhaps by the shockwave of a nearby supernova, began to collapse under its own gravity. As the cloud contracted, it started to spin faster and faster, just like a figure skater pulling their arms in during a spin. This spinning motion caused the cloud to flatten into a rotating disc, much like a pizza dough being tossed in the air. At the center of this swirling disc, gravity pulled most of the material inward, forming a protostar. Temperatures and pressures at the center became immense, so immense that hydrogen atoms began to fuse, releasing an incredible amount of energy and giving birth to our sun. As the sun ignited, the remaining gas and dust in the disk continued to swirl around it. Over millions of years, this material began to clump together like dust bunnies forming under a bed. These clumps grew larger through a process called accretion, where small particles collided and stuck together, gradually forming larger and larger objects. In the inner solar system, where temperatures were hotter, only rocky materials like iron and silicate could withstand the heat. These materials coalesced to form the inner terrestrial planets: Mercury, Venus, Earth, and Mars. Further out, beyond what is known as the frost line, it was cold enough for ices, such as water ice, methane ice, and ammonia ice to exist. These ices, along with rock and metal, accreted to form the cores of the giant planets, Jupiter, Saturn, Uranus, and Neptune. These gas giants, with their immense gravity, pulled in vast amounts of hydrogen and helium, forming their thick atmospheres. This process of planetary formation, driven by gravity and shaped by temperature, resulted in the diverse array of planets we see in our solar system today. Section 4, the Sun, our stellar guardian. At the heart of our solar system blazes the Sun, a star of unimaginable power. This giant ball of hot gas is the reason for our existence. It bathes our planet in light and warmth, providing the energy necessary for life to thrive. Without the Sun, there would be no Earth as we know it, just a frozen, lifeless rock adrift in the vastness of space. The Sun's influence extends far beyond just providing light and heat. Its immense gravity is the glue that holds our entire solar system together. Each planet, moon, and asteroid is locked in an intricate gravitational dance with the Sun, orbiting it in a delicate balance that has been maintained for billions of years. The Sun is not a static object, but a dynamic and ever-changing star. Its surface churns with massive storms and eruptive prominences that send streams of charged particles known as the solar wind hurtling through space. These solar storms can have a profound impact on Earth, disrupting communications, affecting power grids, and creating dazzling auroras in the polar skies. Section 5, Earth, a cradle of life. Our home, Earth, is a remarkable exception in the vastness of space. It's the only known planet to harbour life, a testament to the delicate balance of conditions that make our existence possible. From the highest mountains to the deepest oceans, life thrives in a myriad of forms. But what makes Earth so special? What unique factors contribute to its ability to support such a diverse array of life forms? What allowed life to flourish on our planet while other worlds remained barren and inhospitable? The answer lies in a combination of several unique factors. The answer lies in a unique set of circumstances. One of the most critical factors is Earth's position in the solar system. Earth resides in what astronomers call the habitable zone, a region around a star where temperatures are just right for liquid water to exist on a planet's surface. This zone is often referred to as the Goldilocks zone because conditions are not too hot, not too cold, but just right. Water is essential for life as we know it, and its presence on Earth is a key factor in our planet's habitability. The abundance of water in various forms, oceans, rivers, lakes, and even underground reservoirs, provides a stable environment for life to develop and evolve. Earth's atmosphere, a protective blanket of gases, plays a crucial role in sustaining life. This atmosphere is composed of multiple layers, each serving a specific function. It shields us from harmful solar radiation, regulates our planet's temperature, and provides the air we breathe. Without this protective layer, life as we know it would not be possible. The atmosphere's composition, with its delicate balance of nitrogen, oxygen, and other gases, is perfectly suited for life to thrive. This balance has been maintained over millions of years, allowing complex ecosystems to flourish. Furthermore, Earth's magnetic field, generated by our planet's molten core, acts as a shield against the constant bombardment of charged particles from the Sun, known as the solar wind. This magnetic field is crucial for maintaining the stability of our atmosphere. This invisible force field deflects most of these harmful particles, protecting life on Earth from their damaging effects. Without this magnetic shield, our atmosphere could be stripped away, leaving the planet exposed to the harsh conditions of space. Section 6. Mercury, the sun-baked messenger. Mercury, the smallest planet in our solar system and the closest to the Sun, is a world of extremes. This tiny planet, only slightly larger than Earth's moon, is a fascinating subject of study for astronomers and scientists alike. It's a place where the Sun dominates the sky, scorching the surface with temperatures hot enough to melt lead. During the day, temperatures can soar up to 800 degrees Fahrenheit, while at night they plummet to minus 290 degrees Fahrenheit, creating a stark contrast between day and night. Yet despite its proximity to our star, Mercury harbors secrets beneath its cratered surface, hinting at a more dynamic past. Scientists believe that Mercury's core is unusually large for a planet of its size, which may have influenced its geological history. Named after the Roman messenger god, known for his swiftness, Mercury races around the Sun at an average speed of 107,082 miles per hour. making it the fastest planet in our solar system. This rapid orbit means that Mercury completes a full revolution around the Sun in just 88 Earth days. This rapid orbit, combined with its slow rotation on its axis, creates a peculiar phenomenon on Mercury. A single day on Mercury from one sunrise to the next lasts 176 Earth days, which is twice as long as its year. One day on Mercury from sunrise to sunrise lasts twice as long as its year, which is just 88 Earth days. This means that if you were standing on Mercury's surface, you would experience extremely long days and nights. Mercury's surface is a testament to its violent past, scarred by countless impacts from asteroids and comets. These impacts have shaped the planet's landscape, creating a rugged and heavily cratered terrain. These impacts have left behind a heavily cratered landscape resembling the surface of our Moon. However, Mercury's craters are often deeper and more densely packed, providing a unique record of the early solar system. However, unlike the Moon, Mercury's surface also features vast plains of smooth volcanic material, suggesting periods of intense volcanic activity early in its history. These volcanic plains cover large areas of the planet, indicating that Mercury was once geologically active. One of the most intriguing discoveries about Mercury is the presence of water ice at its poles. This discovery was made by NASA's MESSENGER spacecraft, which detected bright patches in the permanently shadowed craters. Despite the planet's scorching temperatures, these permanently shadowed craters act as cold traps, preserving water ice that has likely been delivered by comets and asteroids over billions of years. This ice provides valuable clues about the history of water in our solar system and the processes that have shaped Mercury's environment.